Hey guys, so in this video we're going to be going over some mainly just definitions. So if you find your packet 2, all right, so we should be looking at our um, whatever I named it, the September 8th to whatever it is, October 1st packet, the thick packet that you received in class either Tuesday or either Thursday or Friday. All right, we're looking at the very first page, lines and angles. We are going to go over these definitions and the practice of them during class, but I want to go ahead and get the definitions out of the way. So I'll go ahead and show you all of these at once. All right, these first 3 definitions, parallel lines, skew lines, and parallel planes. So go ahead and write these down. Pause this video, write these down, and then I'm going to talk about it. So pause me right now. So let's talk about each one of these. So parallel lines is the first one. It says are coplanar. Let's have a refresher. What does coplanar means? On the same plane. Coplanar lines that do not intersect. All right, those are the key things there. If you see these 2 symbols right here, the little lines, that means it's parallel. So we have A to E, so we find A to E here. A to E is parallel. Let me actually do this in black, because my example's in black. A to E is parallel to B to F. They're on the same plane, so they're on the same side of the box, and they are parallel, so they will never touch each other. All right, so that's what parallel lines mean. Skew lines, it says non-coplanar lines that are not parallel, so they're not parallel, but they also do not intersect. So what that means is if you take A to E right here, all right, we're not going to take any of its parallel lines, but we're also not going to touch it. So just as like reference, its parallel lines could be that, this one, and this one. All of those lines that I just highlighted are parallel to our blue line on the same plane, and they would not touch it, right? But that's not what we're looking for. So we know those are out of the question. And then we do not want to touch. So H to G right here, right? If we were to extend both of those lines, I know it's a little hard to see. You would think they were going to intersect, but they're on 2 separate planes. They're not touching on the box, so they're not going to intersect. So those 2 would be skew lines. They're not on the same plane, so they're not on the same side of the box, but they also are not touching each other. Right? When I say touching, like E to H right here would be touching the blue, so that would not be a skew line. And then last but not least, it says parallel planes are planes that do not intersect. So if you're looking at multiple planes, so plane ABCD, like the top of our box, is going to be parallel with plane EFGH, the bottom of our box. Parallel planes not touching each other. All right, on the rest of this front page, you have a lot more definitions. I've spaced them out and I've drawn another thing off to the side so that you could use that. So let me get to that page. So right below, we have what is called a transversal. Let's go ahead and pause this and take this vocab word down. So it says the transversal is a line that intersects 2 or more coplanar lines. So you just got 2 lines that are on the same plane. All right, so here are 2 coplanar lines. I'll do, so this line and this line are two coplanar lines, and the transversal is what's cutting through them right here. That's labeled T for us. There's our transversal, right? It's going to be super important to know that that's called a transversal, right? Because that's going to come up in the rest of our definitions. If you notice, we have an interior and an exterior section. Interior is in what it would sound like. It is inside of those two red lines, and exterior is outside the two red lines. And we see all those different angles that are being formed. And those angles all have names and relationships with each other. So, without further ado, the first one we're looking at is alternate interior angles. So go ahead and pause this video and copy down this note and this definition. So what I've done on my end, I've replicated this picture, this M and N picture over and over again so that I can see what it is. But just as a quick review here, okay, these are our two coplanar lines. They're on the same plane together. And then this line cutting through is our transversal. So our first portion of angles, it's called, these are going to be very, very important to know the names of and know the examples of them. Alternate interior angles. So alternate interior angles means non-adjacent. So that means not side by side. We are on the inside. We are interior angles. And we lie on opposite sides of the transversal, but we're not side by side. So those are kind of the big key ones. So first, we are on the inside of our transversals. So we are in between the two red lines. Okay, so we're inside them. Our inside angles are 2, 3, 7, and 6. So let's choose one angle as an example. Let's choose angle 2. Our pairs would be angle 2. And so we're going to find its alternate interior angle. So we're on the opposite side of the transversal. So on the other side, we're either 7 or 6. But we are non-adjacent. So we are not side by side. So it'd be 2 and 6. They're across from each other, diagonal. So an angle 2 and angle 6 would be one pair of alternate interior angles. And then the other pair would be 7 and 3. Our other pair of alternate interior angles. Let me do that in a different color. It's kind of hard to read. So alternate interior. Moving on to the next one. I have duplicated that picture just for my own drawing so you can see it. You may want to duplicate it as well. Kind of up to you. So go ahead and pause me and write this definition down. Once again, we have our two parallel lines. And we have that cut by the transversal. But now if we read this definition, we are interior angles still, but we lie on the same side. That's why we're called same side interior. We're on the same side and we're inside, interior. You know, up here we had alternate interior. We're inside, but we're on alternate sides. So for this one, if we do some examples here, if we again start with number 2, angle 2, we are on the inside. So again, we're looking at 3, 7, or 6, but we're on the same side of the transversal. So number 2 is above our blue transversal line. So we're going to go with angle 3 because it is also above the transversal line. Then our other set of same side interior angles is number 7. And then it's below the transversal, so we're going to be paired with angle 6. So you see, depending on which type of angle you're looking at, will change what their names are. Okay. Our next one, whoops. We're actually going to come back to corresponding. And so go ahead and write both of these down. I'll come back to corresponding in a second. I'm actually going to talk about alternate exterior angles, but go ahead and pause this video right now and write down these definitions. So looking at alternate exterior angles, still have our 2 lines here. It's cut by a transversal. All right, alternate exterior angles, we again have non-adjacent, so not side by side. This time we're on the exterior portion, and we're still on opposite sides of the transversal. So if we're on the outside, right, is the key, exterior, we are outside of our red line. So we are not in between them. So if we're outside our red lines, we're looking at 1 and 8 and 4 and 5. Okay. So exterior angle, so if we start with angle 1, our alternate exterior angle, we are still on the outside, so we're looking at 8, 4, and 5. We're non-adjacent, so we are not side by side, so it can't be 8. And we're on opposite sides of the transversal. So 1 is above the blue transversal line. So we're going to go with 5. So 1 and 5, they're like, think of alternate exterior angles as being as far away from each other as possible. They're across the diagonal from each other. They're both outside our lines, and they are both on opposite sides of our transversal. So angle 1 and angle 5 would be one pair. And then our other pair would be angle 8 and angle 4. Let me write that more clearly. All right, so far we've had 2 pairs of each type. Corresponding angles have 4 pairs. I guess in this situation we will have 4 pairs. Sometimes it may be more than that, but at minimum they have 4 pairs. So corresponding angles, it says it lies on the same side of the transversal and in corresponding positions. That's not overly helpful, is it? So let me do something here to kind of explain what corresponding positions means. Let me make this box. Let me pause for a sec. All right, so corresponding angles. Say this one at a time. We still have our 2 transversal, our 2 lines, and the transversal through them. So let's focus right here. Pick one of the points. We've got angle 1 right here is in the top. If we just focus in those 4 corners, it's in the top left-hand corner, right? And so if we look at our box and we cover up that side and look at the other, your corresponding angle is going to be in the same spot. So that was in the top left-hand box. So our corresponding angle is also going to be, so top left-hand is in the top left-hand. You kind of see that? Both of those are in the top left-hand side of the other set of 4. So we would have angle 1 and angle 3. Another pair would be angle 2. Let's get that in black. Angle 2 and angle 4. We keep going, we have angle 8 and angle 6. And then lastly, we have angle 7 and angle 5. All right, so those are all the definitions that we're going to cover today. All right, we will do the practice and all of that, all of those practice problems when you come to class on Tuesday. So if you are confident with all this and want to go ahead and start on those practice problems, go for it. But we will be discussing the practice problems Tuesday during class.